Okay, cool. I feel like I think we got some friends in the back, but I think that's okay. All right, we're just gonna start. I hope I'm not intervening. All right. Thank you all so much for coming. I think we can start the show now. But before I jump into the actual content, I just wanted to quickly introduce ourselves. So we're called Clay. We're actually one of the co-hosts today. And who am I? I'm one of the founders. I'm the co-founder and CEO of Clay. The co-founder and COO is managing the live stream right here. And just wanted to quickly introduce what we do. We're a hiring solution, and we tailor it for startups, and we tailor it for software engineer hiring for startups. And the reason is, I think when people try to hire these days, people go to Upwork or Fiverr or other relevant hiring platforms today. But if you've used it once, I think you know that it's a lot of problems. It takes time because you have to interview all of them. So we built a system where we source and then interview all these people on your behalf, and then introduce them to you, and we don't charge basically like a one-shot expensive recruiting fee. That's kind of how we're trying to disrupt the recruiting market and the incumbent model. I also want to give a quick shout out to one of the sponsors today. It's called Open Network Lab. It's actually an accelerator ran by a company that owns this building, which is called Digital Garage. It's on that wall. They invest around $100,000 per startup. So if you're interested in a very low equity taking accelerator, should be good to look into it as well. And a little PR on future events that we do. We're hosting a startup pitch night next Monday here as well. In July, we're fortunate enough to co-host a panel session between the CEO of Plaid, Zach Parrott. So that should be very, very interesting as well. And then later in July, we're doing another AI talk at Clay, which is something we always do often. We have a guy from 12 Labs, also another interesting company called Pepper Labs, which should be interesting as well. And then, sorry, that date is wrong. The hackathon will be on July 26 or 7. Check back in later. Last slide, this is a little campaign that we do whenever we host events. We're offering 400 engineering hours as a discount for anyone that books a demo within the next 48 hours. You can just go to clay.ai, our website, qlay.ai. And that's a little thank you for coming to our event. That's it. That was a little hello from one of the co-hosts. Would love to maybe quickly jump into the actual content. Oh, sorry about that. Okay. Maybe I'll hand over the mic to...
Hey, how is everyone doing? Well, we have a light crowd here, but this is always cozy when you have a smaller crowd and we can have very good, interesting discussion. My name is Khurshid Hassan. I am the founder of Cloud IDR. Before that, I was at Amazon Web Services running the different product groups there. Cloud IDR is inventing a new category called Flex Compute. We are a Bay Area-based company, very deep experience in cloud infrastructure and storage. We have a couple of offerings. A raise of hand, how many people use cloud here? All right, 3 or 4 folks are here using cloud, but as you scale, as you build your business, you have to do it on cloud, right? And very quickly, folks will realize that the cost is super high, especially for younger companies, smaller companies who do not have the weight of an enterprise customer. What we do is we actually help you reduce the cost of your fluctuations, your bursty traffic, as well as your baseline. And how do we do that? That's some secret sauce. But at the end of the day, what you get is up to 40 to 75% lower cost for different types of workloads. And the beauty of this thing is there's no contracts, no commitments, so there's no underutilization, which you will tend to see a lot if you kind of go and do long-term contracts with the cloud providers. And this all works inside the hyperscaler, so you don't have to change anything from your cloud environment point of view. This is a quick slide. This is not a sales slide. This is actually help you understand how we place or position ourselves among all the major primitives within the cloud, from on-demand to spot to reserved machines here. And it's perfect for a lot of workload, including AI, ML, inferencing, and training, what we're going to talk about later in the panel. And finally, if you think there's a value, reach out to us. We also have a booth behind there, and we are offering 2 weeks of free compute, which can be quite a bit of money to help you kind of play it out and see how you can lower your cloud cost. Again, my name is Khurshid, and my senior product manager, Aswin, would be there at the booth behind. Thank you so much.
Hi, everyone. I am Nazrul, founder of Cloud AI. We also have a booth in the back. My co-founder and CTO is in the back. So what we do is we help you take your AI prototype or early stage product and help you.
Proven wrong. All right, so we're going to start. I'm going to ask each of the panelists here. I'm going to put a context first. The AI stack is very deep. It starts all the way from silicon, NVIDIA, all the way to other GPU makers, the cloud providers, and it just goes all the way to application. And we're talking today about application. So from each of the panelists, what is the most important thing that is popping in your mind in terms of how to optimize this stack, or where you think the opportunities exist? Maybe we'll start, Mohit, with you first.
Yeah, so in terms of optimizing the stack, definitely starting with, there's a few things that come to mind when I work with all my startups. One is eval testing, so testing from all the way to the top of the agents, right? So red teaming is one of them. Cost optimization is another one, but that's a little bit lower. I think those two are the most important that I'm seeing nowadays.
Okay, yeah, that really aligns with my experience, honestly. Because when I think about optimizing the tech stack for building LLMs, there's kind of two things that come to mind. One is a standardized process that can be used across a company. Maybe not so important in a startup context, but definitely important in the enterprise context. If you have a lot of different teams who are trying to tinker with AI and build prototypes and get them in front of business leaders, if they're all going out and finding their own different set of tools to use for that, it's going to take them a really long time. But if you have like a core platform team that can kind of curate those tools and provide it to the AI practitioners, that can really speed up development. So it's not so much like, hey, this is the tool that you have to have. It's really just kind of that unified approach and providing that to the researchers and developers. They don't have to spend their time figuring that out. And then the other piece is evaluation, like measuring the success and accuracy of these LLMs is really difficult because it's not just a numeric output anymore, it's language, and measuring the accuracy of language is a very challenging kind of mathematical problem. And so I see the most successful projects are thinking about that in the development phase and not really waiting to production and then thinking about how they're going to monitor and evaluate. So that consideration for the eval metrics is made very early on in the development.
Yeah, so at Cloud AI, we constantly think about productivity, right? So we think about how you could do things that would help you increase your velocity. So that's kind of like one of the optimization we always think about. In terms of like runtime optimization, lately we went through one iteration of that, and what we noticed is you write your code and you think you have done everything, but then when you kind of take a fresh look at some bottlenecks and like performance issues, and you realize that there is always the next level of integration you could do and improve things. So we have gone through those. That's fresh on my mind. In terms of LLM, like what LLM to use and cost consideration, that's also like a big one because you can obviously use the best LLM in town for something, but then the cost, so if you think about price performance, then you kind of begin to wonder, what's the kind of the best combination. So we have actually done that lately as well in terms of like what actually is the important LLM for certain type of task. So instead of like picking one LLM, we ended up like choosing several for different kind of workloads. So you may run into similar kind of issues if you have not done that already. And obviously the infrastructure, right? There's a lot of cost that you may be incurring from your AWS infrastructure. So if you're not paying attention to your bills, the bill might be slowly growing. And that was happened with me as well. So I was talking with Khurshid over a lunch, and he heard what my bill was, and he said, "You're definitely paying too much. Like you should take a look." And then we started tightening our belt, and we found actually a bunch of fat that we could cut out. So yeah, like there are like several kind of optimizations you can do from developer productivity in terms of hiring. Also, obviously, if you are hiring remote teams worldwide, understanding how to hire smart and kind of delegate some of the kind of like how do you like recruit engineers worldwide and not have to deal with all the paperwork. Those kind of things is also important consideration.
You said Nazrul is going to take all of my 3 other questions outside my shop. But before, so we
Hemant here. So Hemant, we just did the introduction, so maybe you can do a quick intro and talk about like the optimization question from your perspective. Yeah.
So Hemant Puddaswamy, and I'm CEO and co-founder of this company called Malbec. We are a contract lifecycle management solution. We help manage contracts for Fortune 500 companies like Takeda, Genentech, and many other large firms. So what's the question?
the question is that in the whole stack from chips to the application, the middle layer, what is grabbing your attention? What is at the top of your mind where you think there is an opportunity to innovate and optimize and whatnot?
Sure. So throughout the stack, one thing that, like there are a couple of layers where LLM has done a good job or doing a decent job, particularly the user interface. So we use quite a bit of that. Our product managers, now I don't have a UX person anymore, I had. And product managers comes up with new ideas and they generate the Angular, HTML, like all this code snippet and make it interactive so they can communicate better. So definitely the user interface layer, it's working out well. Our developers definitely use Copilot, and what also has worked well is, like taking smaller pieces of modules and then trying to work within that. It works pretty well. If you want to take that code outside the context and work within that context. So yeah, quick prototyping, the productivity has definitely gone up, but when you have a large context, it's not working out so well, for sure.
Yeah. So my turn. So I'm a infrastructure guy, and when I look at applications, I look from a viewpoint of a lens of how infrastructure affects the overall application performance as well as cost. And there is always this trade-off between performance and cost, and I would say velocity as well, but velocity translates into cost. So to me, I'm looking at the sort of a number of startups and established companies that are coming out offering GPU as a service, offering AI as a service, and competing with hyperscalers, while hyperscalers are also rapidly expanding their offerings. So to me, it's becoming a very hard choice for end business owners and companies who are building the applications to say, look, which path should I select? Should I go and build my solution within a hyperscaler and pay a premium price? But the trade-off is that it's more reliable, it's more scalable, it is more available, versus go to some small parties and have a very narrow niche and build an application on that. It saves you the initial cost, but maybe it doesn't allow you to scale with all the additional services that a hyperscaler offers. So that is always the top of my mind, and as we build Cloud Idea, we're always kind of evaluating what's the best way and what best offering we can provide to our customers. My next question is that you are a developer, Claire. So tell us a little bit about your AI tool chain and how that affects your efficiency or your velocity.
Yeah, great question. This is actually something I've been experimenting with over the past few weeks, and I'm sure a lot of you guys are as well. I have started my journey with AI-assisted coding and vibe coding. I was a little bit resistant to it, like being a software engineer myself and thinking like, oh, I already know everything, why do I need AI? But then I wanted to really speed up my development, and so I started tinkering with Cursor AI, and that's just one of them. There's other ones to look at, but personally I've adopted Cursor into my workflow. And I built a project that in my past life probably would have taken me 3 months, and I did it in a week. But I learned a lot through that process of using the AI to help me generate code. I learned that my background is still relevant because I needed to steer the AI, and it really produced some really bad code that violated a lot of best practices, and if I didn't know that, I would not have been able to steer it properly. So it was this kind of back and forth collaboration with the AI to come up with code that worked. I don't think that this project would have worked at all if I just asked it to just generate this project idea that I have. I actually had to have the coding experience to be able to speak the right language, describe what I needed to build, and I had to have a vision of what the code base would look like and force like modular design and best practices. So my takeaway from that is that I think our job as engineers and developers is very much safe from AI, but we do need to work on integrating these new tools into our workflow, and the way I'm doing that is every new project that I take on, I just try to find a new tool, learn it, and use it in the project.
Anyone else wants to add anything to it?
So definitely we have experimented with Cursor quite a bit.
Yeah.
And Cursor, one thing is sure, it's art than more engineering. The way you ask the question, the prompting, the context, so all that matters. And what I've noticed is there are smart engineers who can get the best out of it, and there are not so smart, or like the new engineers, they get the worst of it. They take longer because they don't get to accomplish what we need to accomplish. So I think that smartness and then that art of prompting is key to the success. At least that's where we are right now. But the way it's gaining traction and the way people are able to use it, it's amazing. Great things are coming.
Before I was an investor, I was an engineering manager at DataRobot, and I left about in November of 24, and GitHub Copilot was just starting to gain popularity at that point. The thing that I noticed when that came out and my engineers started using the Copilot is that you can write a lot of code very quickly, but a lot of that is not going to be production ready. They're not going to think about the design decisions that we need to make. Will it scale? Will it scale with additional users? How does it handle database load as well? So these are all these design things that you need to think about that the AI will not think about it for you.
Yeah, I think tied to this is maintainability, right? Who can maintain it and how it kind of works through the structure that you want to build in the company. So then what is your opinion? I mean, many people here in this audience will be saying, hey, look, I'm going to use Cursor, I'm going to use Anthropic and Copilot, I'm going to crack my startup pretty soon. What's your advice to them? Like, you have to have a super smart engineer, like you're saying, or anybody should take it and do it?
No, I think the most important thing is the idea. So the idea has to be solved. It has to solve an important need, right? If you're solving an important need, and how fast you can solve it. And this is one means of getting there. Fast means of getting there, but as I said, like if you have smarter engineers, they can figure things out very fast. Like Clay was saying, 3 months, 1 week, yeah, that's definitely possible. But there will be bad code. You need to make sure that whatever you're putting out to be production ready, as you were saying. I mean, we have put some parts of the code into production, for sure. But there is, there is more, like we do the vetting, extra vetting, just to make sure it's going to work correctly. So as long as the senior engineers are there and the right idea is required than anything else. But apart from that, it's not about building one small piece of the equation. Whatever you're solving has to be something big and something that others cannot do as fast as you can do. So those two things. I mean, it's generating 1,000 lines of code or 5,000 lines of code, fine. It can do it. But are you solving a particular problem that no one else can solve better than you?
Yeah. One thing I experienced is you can generate a lot of code with cursors of the world now. If you do vibe coding, you can do the UI, UX quite a bit. We actually incorporated that in our development workflow. So instead of like trying to do everything the right way, we just do vibe code and come up with the UI to kind of get to the prototype quickly. That translated really well for us internally. And we are from the opinion that you should have strong fundamentals. Like you should not like skip things like code review, writing test in your pre-commit workflow, those kind of things. So if you skip those, then obviously you're shipping very flammable code. But if you stick to the fundamentals, but incorporate intelligent tools, and there are lots of tools that are available that can speed up your development quite a bit. You can easily get 20 to 40% productivity. Now that sounds like okay maybe, but like if you really do the math, it's substantial, right? 20% means your Friday you're free. Think about it, right? You have free Friday. That's like a lot of freedom, a lot of new things you can do. So yeah, definitely look out for interesting startups, tools that would help you do things smarter.
You guys are seeing any specific actions that folks need to take when they are prototyping, let's say AI agents? And prototype is one thing, MVP is one thing, but when you have to go into production, you have to think about a bunch of other things, right? Any recommendations, any thoughts on this? Maybe we'll start from there and we'll move this side.
So AI agents definitely, like it's evolving, as we all know. But the most important thing is, it's not about just trying to get something done quickly. I'll give you a simple example. One of our architects, he came up with the first version of the solution where it can take the output and then generate an HTML and make it look beautiful. And then that consumed 10 times more token than it would do otherwise. So we ended up doing a lot of optimization, and that's where we spent a lot of time, and then we were able to do that with Markdown and able to get that information in a much more optimized way. So what I was trying to say is, it's not about, okay, if an agent can get that particular information, it's about how fast and how optimized it is to be able to be economical, to be able to serve in the best possible way, one. And two, non-determinism is a major issue with all this. How do you make it deterministic? Like we deal with contracts. If you're dealing with contracts and if our customers, Fortune 500 companies who are using it, if I give them inconsistent answers every time, then they will not use it. They will not use my solution. My credibility is gone. So those are some of the things to take care of, where if you're building something, you need to have some predictable results. The prompt engineering, the context engineering, and all that is very important. And along with that, the cost, the economies of scale, all of those things you need to keep in mind.
Right. Yeah, I have similar observations actually. So the vagueness of what your agent would return, because you are not dealing with very static inflow and outflow, right? So if the agent returns something that you have not tested or you don't know how to handle, then your customers end up getting very weird or surprising results that you don't want. So you definitely want to test, make sure that what you are producing is what you intend to deliver. That I would say the kind of like the elephant in the room. It's always easy to kind of do a quick prototype and get something, but delivering enterprise quality requires a rigorous, mindful testing. That's one thing we definitely noticed. And the other thing I noticed is the evaluation, right? Phase one was the chatbot, right? You have assistant. Everybody was very happy with delivering an assistant. Now assistants are no longer cool, right? You need to deliver agents, and you want to have these agents solve a complex workflow problems. That's where I have seen a lot of work these days. And then the next phase is autonomous agents, right? You don't want to even worry about telling these agents how to solve problems. You want them to kind of go ahead and be intelligent and solve it, right? And then you want lots of agents to talk to each other and do very complex, interesting problems. So I think we are kind of at the second phase at the moment, where I have seen a lot of credible agentic startups solving problems. And obviously there are startups that are coming up with infrastructure that will allow you to run 100 agents concurrently and all of that. So things are getting a lot more interesting. One thing I would say is, if you are on the fence about should you do agent or not, then I would definitely say that think about it, because you don't want to be 20 to 30% slower, right? Or less intelligent. In the long run, if you think about it, the economy will dictate that you do this, right? So you don't have a choice not to do it.
So what are the knobs here to get this latency reduction? How are you thinking about it? What's the tricks under the cover? Anyone can take this question.
I will defer to Claire because she's the boss here.
I've messed with it a little bit, but I would love to hear everyone's perspective. In terms of like latency reduction, the first thing I actually think about is the architectural design of the code. Like, how many steps do you have in that architecture diagram? What processes are happening where? Can they happen in parallel? So it's really stepping back, look at the entire system that you're designing and thinking about what is the end user's experience. Are they sitting there waiting for a response from your app? And how can you speed that up? Is there stuff you can store on the side? So it really just comes to like the architecture design. And then the other thing that I've actually experimented with quite a bit is prompt engineering. the best prompt I ever engineered, I just asked ChatGPT to write the prompt for me, and I told it what I was trying to do, and it actually ended up being the most effective prompt that I've put together. The prompt was shorter, which ended up saving me some cost, and then also just like forcing the output to be shorter. It depends on what you're building, but like typically you don't need like a huge novel as the output, so really constraining that as well. So really just optimizing your prompt, optimizing the length of the output for the use case, and then also like thinking about latency and cost when you design the system in the first place.
Any thoughts? Are you seeing any companies out there which is kind of tackling the agent performance or agent workflows, which is at the top of your mind?
Yeah. In terms of that, I think the testing part of the AI agents is the most interesting right now. And you know, my experience as an engineer is we didn't do AI agents at that point. You know, it wasn't a huge thing back then, and like a year or two ago. But the thing is that when testing, I think that agents or developers are really bad at writing test cases. Might be a hot take, but for some reason, we had Japanese customers. They were amazing at breaking our code. Like they would have upload very wide data sets, Unicode. I don't know what was like good about them, but they broke our code a bunch. So what I really recommend is having observability around your code. See how your customers are breaking your code and try to remediate that as well. So I think those things are the most important.
I haven't developed agents, but based on developing software for a very long time, and I think same principles applies here as well. Seconding what everybody else said is, to me, having a system engineer or an architect who are looking at your whole architecture and sort of as you're developing, fine-tuning along the way. You don't want to be in production where you sudden jump in the volume and finding out all the nuances and bad design practices that have gone into it. So from day one, from day zero, as you're putting together your block diagrams, as you're defining that architecture, you need to be very, very cognizant of what's the right approach and how you are building a scalable platform from very early on. Now, there's a thesis out there that build MVP fast, throw it away when you have the product market fit and redo everything. I'm not one of those guys, so I usually don't do that. But this is again a philosophy, and people can go whatever way they want to do that.
Yeah, in our case, so for code review, we do a set of activity to evaluate the code, right? So we have different agents doing different things. So we have one agent that looks at security, and there are two aspects of security we look at. So we look at the kind of like the web application top 10 security standards. We also have agentic AI security, ASI standard, right? So if you happen to have both of the codes, or you would look at both. We also have your regular CNCF evaluation. Let's say if it's a Kubernetes application, so things like that. We look at logic, those kind of things, and then we also look at few other branches of the code, right? So it ends up being like 4 or 5 agents that need to be executed. So recently when we were doing the performance optimization, we looked at it seriously to see like how long we are spending on different threads and how can we optimize so that the response time is reasonable. The other thing that we found is different models, response time is very different. So depending on which model you are calling, your response time could be like 7 seconds to like 30 seconds. Which we found very interesting that the difference is that much. Like if you are using Anthropic, and if you are using OpenAI, their response were similar in our cases, but Grok was blazingly fast. We found Grok to be the fastest. Take a look at your LLM responses. If you are kind of worried about overall turnaround time, you will find some interesting numbers there. And then also, if you are writing agentic code, then how many agents are you running, and could some of them be parallelized? Would definitely reduce your overall response time. One other trick that we are looking at doing is instead of waiting for everything to finish and then respond, start doing streaming, so that you behave like OpenAI. And people, as soon as you start responding, then people think okay, you're responding. So that you can reduce the wait time. So that could be another interesting trick you can do.
I think it's very, stepping back a little bit, even not from the code perspective, but from the business perspective. If quality doesn't make a dent in revenue, it doesn't increase in your revenue, just pick the cheaper model. It'll save you a lot. It'll save you a lot of time and money.
Right.
Yeah, so the interesting thing is, again, you were talking about doing something quick and dirty. You definitely don't want to do it. Yeah, I would advise, just because it gives the illusion of accomplishment, right? You don't want that illusion of accomplishment. You really want to make sure that whatever you're developing, if you're developing agents, let it be super specialized. Make it very contextualized, right? Let's say in our example, I'll give you a simple example. We have agents where it can go find specific types of legal provisions, specific types of commercial provisions, specific type of terms. So it operates within that smaller context. So the amount of context, the amount of input and output is going to be smaller, but much more grounded and accurate. And all those things are important. All the things that you guys are talking about is very important. I mean, if you have to put it in the production and you give it to the customer, and then the customer say, if you say your question, it will take about 15 minutes to get the answer, they will not have that patience. So if you're dealing with thousands of contracts, sure, even that, the expectation is different. But having that super specialized agent with optimized engineering minds, so that engineering thing that you guys learned, that should not go away. So you can apply it still and do it better. You can use this as one of the means, one of the tools, but you can do it faster. But at the same time, if you have to put it to production, it better be good quality, predictable quality.
Super. I don't want our audience to fall, right? Questions? Yes, please. Take the mic there.
Hello. Awesome. Thank you so much for the different insights. So, question, you mentioned determinism, consistency, and predictability. Can you give us a few tips and tricks on how you enforce that or maintain that in your prompts and AI agents and applications? Concrete things you can share. Thank you.
Yeah.
Thank you.
So Claire was talking about concise prompts. In our case, it is reverse. Our prompts are pretty big. Why the prompts are pretty big? We do put situational questions. If this is the kind of situation, this is the expected response. So, we have come up with recommended responses in this kind of situations. So examples are extremely important. In the prompt that you're doing, if you want determinism, examples are extremely important. And also, as I said, we have super specialized agent where instead of solving everything under the sun, We have divided that into smaller pieces so that we can focus on that particular concepts. So the context window that you're going to feed, that also has to be very narrow, right? When I say narrow, it does not have to be extremely narrow where one sentence or two sentences, but it has to be predictable. Every time you give the context, you're giving the same kind of information in 7 categories rather than 150 categories, as an example. So the input categories that you're going to provide for that super specialized agent with possible answers and giving that kind of guidance is extremely critical. So that is one of the things that we have seen. But the context engineering, I cannot say enough of it. One thing that we learned is like we build something and then we put it in the sandbox, ask customers to test. It worked beautifully when we built it, but when customers tried with different kinds of contracts, different variations, different kinds of questions, it started giving so many different kinds of answers. So that's where we started learning. The other thing that we did was, instead of ask anything, which is what LLM can do, we started giving what is called the guided prompting, where here are the possible 3, 5 prompts that you can use as an end user. And we parameterize those prompting, where you can just speak and then it will say, okay, these are the 7 parameters that you can change. So it gives a guidance to the end user what kind of questions make sense. It is frustrating if you ask a question and you get different answers, but then if you start giving deterministic prompts with deterministic results where they can change some 10, 12 things and then get consistent answers. So those are some of the things that we have done. It has worked well.
I like that. I think to add on to that, part of the beauty of the agent architecture that really resonates with me these days is the modular design. So it's not so much a concise prompt, it's just a very focused prompt. And you have many different kind of modules probably within your architecture, and each one has its own specific task. So when I first started developing with AI, I would just like shove everything into a really long prompt, and I was asking it to do a lot in one prompt. And then if something goes wrong, I couldn't really pinpoint where in my prompt to fix it. But if you identify those different tasks within the prompt, and each one is its own kind of node in your architecture, now if it breaks, you know where to go to fix. And you also are just allowing each agent in this multi-agent architecture to focus on being good at one thing, which it's going to be better at. So that's the kind of design pattern that I would push us towards if we want to move towards more like reliable output.
Yeah. So just to add to that, Claire, also I've seen the other side of the equation where I was talking about the large prompts. Yeah. As the prompts gets larger and larger and larger, of course, when I use the smaller model, it works horribly. When you use the larger model, it works decently well, but there is, like beyond certain size, it will just ignore. It will just ignore. So that is, again, an art. You need to iterate, you need to experiment, and make sure, like if you give 100 examples, there also, it just ignores after 5 or 6. So that's why super specialized task, like task agents, the sub-agents, which can get specific tasks with a specific context.
The last thing I will say, because I love this topic and I don't want to like bore you guys to death, but another thing I want to point out in this context is we're talking a lot about LLMs, and they're beautiful, amazing tools, but they are just a language model. And another thing that I consider in my design is what model am I using for which tasks. So not even just modular design of the LLM agents, but should it even be an LLM doing the specific tasks? So if it's like a data analysis summary that I could actually just code up in Python with direct mathematical equations, I'm going to go to that because that's how you get your deterministic output, whereas the LLM is always going to be somewhat non-deterministic. So really just considering the bones of the model itself and what it's purpose-built for, and then using that to guide each task in the architecture.
Another thing is I recently ran into this bug at one of my portfolio companies as well. You have to consider anything that can change over time that's not coded. Yeah, so one of the bug was that they wanted to use GPT 4.0. The problem was that 4.0 changes, maybe every few days. If your model changes in the back, your output can also change. So really pinning the version down, and then once you want to upgrade that, so you have to rerun all of your tests whenever that model changes. So you can say, okay, today's version. But if it's like 2 weeks out, then that might also change. So we have to rerun all the tests, make sure that whatever examples that you made still make sense.
Yeah.
I have a question. When you're, like a big thing in enterprise AI is the POCs work and then you go to production and they don't. Can you analyze that at all? It's like, where does this stuff break down? Is it the data quality? Is it what?
I think, can you summarize the question again?
So a big problem in enterprise AI is you have a proof of concept project.
Yeah.
It's beautiful, it works on a small data set. You try to roll it out to the big company, it doesn't work. Do we know why that's happening?
So I think if I'm understanding the question is that you have prototype a system with small data set. Now, when you put the more data set, it is not performing as expected. So it seems that the data quality issue is there's just not enough information to train the model or whatever that is. That's my hunch, but.
No, I mean, totally. I cannot stress this enough. When we went to production, right, we do have customers using it. Simple example, the red lines on the contracts, right, the MSA, that is very time consuming for lawyers, as you know. And they've taken previous positions for similar red lines. When there's a red line from the other attorney, it comes and then the system can read and say, okay, this is the ask. Now, what we've done is in that maybe 30, 50 page document, we have broken that into probably 200 small segments. And within that segment, as Clay was saying, we have indexed thousands of those, and then we do a lot of heavy lifting behind the scene. And then give LLM, sometimes we teach LLM like a 10-year-old, right? So here are the 3 different variations for this particular language change and this particular segment. And give me the best recommendations and also tell me why, explain why you came up with it, right? So those kind of things where even though I've indexed thousands of those, I'm not giving all 1,000. I'm able to get the most closest match to that. Of course, it's all about, as I was saying, the context. So the context cannot be too large. The context has to be small. Even though I'm dealing with 20-page, 30-page, 50-page, 50-page document, breaking that up into smaller pieces, you can accomplish some good stuff. Customers use it, they love it. But if you try to, we have the other side of the problem, which is you have customers like Electronic Arts and others who have 500,000, 1 million contracts sitting there. And they want to ask a question and then get the answer. So there, we had to do totally different kind of engineering. Again, lot of core, the foundation that Nazrul was talking about, Claire was talking about, all those things are extremely important. Yeah, the prototypes are so easy to build, but if there is no clear foundation and architecture behind it, then it will be difficult for you to scale.
Yeah, the problem that you're describing is not really a large language model problem. It's an AI problem as a whole, right? So in traditional machine learning, you might have bias and overfitting, which if you deploy that into production, it's not going to perform well in production. Similar thing with AI agents. So you might have to tweak what your prompt is, your examples are. The examples that you provide might not be equivalent to what the customers are using.
I think it's the feedback feedback loop. I think that's
Yeah.
kind of, and that's something you mentioned earlier, kind of thinking about the older systems architecture. Like most AI systems, and definitely POCs and prototypes, do not have a live feedback loop that's improving the system as it experiences new data. In the prototype phase, you probably have a great data set, and you're iterating, and it looks like it's going well, and then you move it in front of a bunch of customers. Now it's going to see new and unseen patterns. And where I personally would encourage all of us to focus in AI right now, because I think it's probably the next frontier to push this technology forward, would be in that feedback loop. How do we collect that data from where it's failing, and then once we collect it, how do we get the system to improve in a circular manner? And then I think it would be quite powerful.
Yeah. The fundamentals are, I think, important in terms of just because it's an AI project doesn't mean that it's any different than your software project, right? So you should be testing your project. You should not. Yeah, it's still software, so you have to know what are the use cases you're supposed to support. Have you tested those? Do you have data for those? So most of the in the frenzy, we tend to forget that if you have not really tested it, chances are you will have some surprises. So I think the fundamentals are important. Doing the right testing and writing the test, going through the data. So Hemant talked about volumes of data. So like, what's your intended customers? Like what kind of data are they gonna bring? Are they gonna bring in millions of records, or are they gonna bring you like tens and thousands of records? So knowing those things, I think, would be a big difference in terms of whether the system can handle or not. And it's no different than any software engineering, right? You need to know the scale. You need to know what you're dealing with. So yeah, like take a breath, think about fundamentals, plan it well, then you'll be able to execute it.
So if I may add one more, the machine learning is not there. Machine learning is not there. So we have the tendency when we do the prototype, yeah, I mean, this is working out well, and I'm ready for the production. But in reality, the machine learning, like the segments that I was talking about, we have our own machine learning behind it, where each piece of segment, we are putting a lot of emphasis on our machine learning. So that, like machine learning with unsupervised learning works better. If you try, I mean, again, that is one of the experiences depending on the use cases that you're working on. But in general, pay attention whenever the large data set, the variability of the data set, all those things comes in. How do you make it go in certain direction that is decently predictable? You cannot make it 100% predictable.
I have one question here. So when the applications are in production, where is the overspending happening? Maybe I'll take a track on that one. So here's my experience, which I call an inflection point. When you're a small company, you are predominantly spending on your engineers. That's the biggest cost. When you hit the rocky stick, there is another factor in SaaS companies, which is, and especially in the AI companies, which is the GPU cost. And I was, before starting my own startup, I was an AWS EC2. I've seen that very up close and personal. So there is this flip that happens, and I think the customers needs to be aware of that, and they need to take preemptive actions, because the bills do stack up very, very fast, especially with the GPUs. You're spending like $8, $10 an hour for one GPU, and if you have a GPU that chassis, that's $100 an hour. So it can be tens of thousands of dollars within a couple of months, right? So some of the things that we used to recommend, or we still recommend in our company, is look at the utilization of the resources that you're using. Turn them down when you don't need them, which we call right sizing. And then if you have a consistent usage pattern, then you go and see what type of discounts that you can get from the cloud provider or whoever your provider is, so you can lower the bill. And then be very careful in terms of monitoring that you are not underutilized. But if you're underutilized, you're throwing money away, you're burning your cash. So keeping that view side of how you should carry forward, and this is not one-time shot. It's like I call cloud or GPU optimization a constant struggle, a constant wheel that you have to be doing it all the time. Every week you should be looking at the reports, you should be looking at it. So that's one of my thinking on where the spending happens when you go into production or high volume. If anybody else wants to add anything.
Yeah, so there's a stat on this. So about 40%, so Series A companies, only 40% of GPUs are utilized. Series A companies. That means 60% are unutilized, and you're throwing away money. So exactly, you can right size it. You can explore reserve instances, spot instances, on demand, all of those, mix and match. Another thing that, in terms of design, that we can look at, or everybody should look at, is rate limiting. Rate limiting and also cost switches as well. So if you're one user is blowing through X amount of money, just kill that job, right? It can also come from a bug, a simple bug, a while loop that doesn't terminate. That'll cost you a lot of money as well. So having these kill switches is very important.
Don't forget cloud IDR. We can cut 40% of your GPU cost. All right. Any more questions? Anything on the online, Toku? Any questions online? Do we have any folks asking anything? Take your question in the meantime.
I'm currently an undergrad studying computer science, and it seems like AI has advanced so much in my 2 years in college, and it seems like it's going to continue to advance. And you guys were talking about vibe coding earlier and how like engineers with strong fundamentals are more efficient and they build better software. So I was wondering if you guys could go more in depth on like what fundamentals current students should learn to break into the industry and build a successful career.
Absolutely. You're in a fun time to be studying computer science, engineering in general. Very exciting time. I think, so what I've noticed is a lot of people talk about, how you need like a really senior engineer to steer the AI. I don't think that's necessarily the case. I think it's more about the skill set that senior engineer has, and I think the skill set that you as an engineer are going to need to have is shifting. So the senior engineer is really, really good at systems design. He's seen a lot of systems, and they've written a lot of code, and they know how to just kind of design the architecture as a whole. And yes, they can write line-by-line code as well. But I think what you're going to get to do less of is the tedious stuff where it's like writing the line-by-line code. You're more going to be working with the AI, guiding it, and like correcting its line-by-line code, but you don't have to type every single line anymore, which means you can put your thought power behind the entire architecture of the system, and I would focus a little bit more there. So really leaning into like best practices around just the architecture side of things.
I agree with it, totally with Claire. I think the trend previously had been anyone can go and run a Python, take a 2-month course, or do a Java course, a Node.js course, and they're good. That's gone, I think, in my opinion. That's going to get deprioritized. System engineering, how do you become a system engineer? The way you become a system engineer or you develop system thinking is to think broad, upstream and downstream. If you don't think upstream and you don't think downstream, you cannot be a system engineer, right? And part of that equation is taking foundational courses, algorithms, data structures. Those are the foundations which helps you to kind of build that mindset. It trains your brain, the rewiring of your brain. So as much as you can take computer architecture, you should take it. Even if you're doing computer science, take a computer architecture course.
I agree.
Yeah, so totally agree with what Claire and Khushit said. Day before yesterday, I was talking to, we have interns, one of the intern that I'm working with. Like you guys just, you're getting introduced to the real world scenarios, right? get exposed to it. I mean, Khurshid said, get all the fundamentals. Very important. Don't be scared. Go deeper into it. Learn as much. I mean, B-tree search, tree, all those things are important, right? How do you optimize every one of these data structures, that fundamentals? But apart from that, how can you be smart in trying to build things faster, better, but also with good quality, right? So faster, I'll give you a simple example, right? I mean, I was asking this intern to build a mobile app with some specific UI. And, you know, like for him, I asked him to use Cursor, build a prototype for me. And for him, it's, again, very new. And don't be scared, right? Ask questions with people around you, right? I mean, like people like us, or people like whoever is, you know, like who has a few years of experience. Tell me how you solve this problem. And then try to mimic that on Cursor. So basically, I made him do the prototype, really build it on PPT, right? Really build a PPT on prototype, and then go feed that one by one, and try to build the screens, and then try to do the interaction. He was blown away on what can be done. So that's something that, because we are exposed to all these real world scenarios, that comes naturally for us. For you guys, it's new. Those are the exposures, apart from all the fundamentals, we should try to get.
So if you also think about like what's being commoditized by these coding agents, the pumping out a lot of code, it can do it very well. What it can't do is very low-level stuff, so like memory management, that stuff. System design is very high level, right? So memory management, data structures, all that stuff, the large language model is not really good at, or it might choose a wrong data structure or wrong memory structure. And you have to go in and fix that. And also, it's not commoditizing very high level. So I think focusing on the very low level and the very high level would be the best bet here.
I'll add one more thing here, it just popped into my mind. So if you see, I think this is not only an age of AI, this is an age of interdisciplinary education and knowledge. So if you are a software developer, but if you can up-level yourself to say, look, I'm building this application, how my customers should be thinking? How should I design this UI, UX of it? Now you have gone and become a product designer as well. So if you can merge the two angles, that is absolutely killer. You are a one-man company. You can do everything.
My suggestion is, apart from learning the fundamentals, try getting your hands dirty. Start building things. That's the best way to learn. At this point, there are lots of tools, so you are not going to be stuck. And if you start solving problems, you will probably learn the most by doing things.
And it builds your resume, personal projects.
Yeah. And you will have insights that will be very valuable.
Any more questions from the audience? We do have pizzas remaining and water remaining. Unfortunately, we do not have any alcohol, Nazrul. I was hoping for something.
We have soda.
All right, any more questions?
Yeah. So we have until 8 o'clock to network. So hang out, grab some food, grab some drink. We are around. And I find these type of meetup, the networking is kind of like the best part for me. So do, take advantage of the networking.
I just want to ask one stupid beginner question, so I can,
If you have a bunch of different modules that you want to break into an architecture of, piece by piece assignment for the agents, how do you link them up, not in the same LLM, so that they're calling upon each other?
I will pass this question to the practitioners here.
Claire?
Each one should be its own LLM, so it's going to have its own prompt and its own call to each LLM. It's not a silly question. It's the
And then it pulls into, then it pulls the answers into a self-prompting last prompt?
Could do that, yeah. So you could have like an LLM call for each kind of module and then put it all together in a final prompt. That might be the right
So
way
like
to do that.
send this to ChatGPT and give me an answer after you pull from all these things?
Yes.
And can that be done like on a retail level, just like in OpenAI? Yeah.
Yeah, I would look at Crew AI.
Crew
AI
AI.
makes this really easy to
Oh.
do. OpenAI will do it too, but I built something very similar to Crew AI and it was easy to do.
Awesome. And okay, one more stupid question. If you were going to like build your own LLM to protect from the iterations and censorship flags of OpenAI and whatever, and you didn't want to like trust Grok to stay truthful, what would be the? I guess that's just like you got to hire an AI engineer and let them kind of guide you with the training. We were talking about this, but
Yeah, you can download your own model instead of, so when you call out to OpenAI, you're basically sending your data to OpenAI. Not everyone loves that. So what you want to do is you want to locally host your own model, and the way to do that is there's a lot of pre-trained models. They're huge, but you can download them and run them. The reason a lot of people won't take this route, though, is it's a bit expensive and time-consuming. So
and you
just
have to have
kinda
your
weigh
own
that trade-off.
server, and it's a
Yeah,
pain
you
in the
gotta
ass.
host it yourself on your own server. But those models are out there, they're open source, and then you can tune them to your use case as well. It's just a cost versus privacy consideration there.
Okay, and is it my imagination or the back end where you API into OpenAI, or we'll just talk about OpenAI, you API into it, and those that would like, display on your own wrapper, are they like much less parameters and stupefied to be like stupid?
No, you get different kinds of models that you can use, right? I mean, 7 billion parameters.
No, I'm talking
yeah,
about right now we're APIing to ChatGPT or OpenAI.
Yeah.
And on our app, the answers are incredibly more homogenized
Yeah.
and retarded than OpenAI, which is great. And I'm like, why is that happening? It's the same ChatGPT, but it can't be. It's got to be limited, and I'm just wondering if there's a workaround to say, please stop treating the answers, like a.
The answers look really different. It could be different models, or maybe you set different
Your
parameters.
mic stopped.
Oh, is it like different models or different parameters, like the temperature?
Your mic is going on.
Hello.
Hello.
It might be different models.
Yeah.
Yeah.
Or
Yeah, I mean, you get good models, you get not so good models. So, like for example, Claude Sonnet versus Haiku, right?
Well, I was specifically talking about OpenAI, like on its API,
OpenAI
is not performing the same as the retail face of.
Yeah, actually, we use, for us, the reliable LLMs are definitely, so far, of all the ones that we've tested, Sonnet,
Okay,
Claude Sonnet.
got it.
And again, as I said, there are times where we feel that it is giving wrong results, but how good is your prompt?
Right.
How good is your context? And how well you're directing the LLM to go in specific direction.
Okay, thank you.
And I think
Thank you.
what you were also saying is that the OpenAI API on this raw level is stateless as well. So you have to be very creative on how you chain responses and as well. Oh, is it working?
It could. I heard 80%.
Okay.
You can hit me after.
Question at the back? Oh.
This is questions for you guys. Like, I'm curious, like, what's next for you? There's a lot of developing and also scaling applications out there. What makes you different to be in the competitions with others, and what's the next step for you? Thank you. Oh, but also for the capital, like, who do you choose? This kind of stuff, like, based on what? for the kind of like the future for you?
Fantastic question, love it. And best question, how do you fund which company?
Yeah. So right now, there's a lot of companies trying to put AI into production. The part where most companies fall short is I've said it, I'm like a broken record, testing, but also compliance is a huge one. Making sure that you're compliant with everything. Guardrails are very important. Making sure everything falls into place would be very important when putting your large language model into play. So like in terms of investments, looking at those areas where anything that helps agents get into production is where I would put my money.
Is it correct, Mohak, that these behemoths, right, these Anthropics of the world and OpenAIs of the world, over time they will encroach more and more in these vertical agents? Wouldn't they just take over the market? And that's why are you saying that you need to go take one step behind and see how to build an ecosystem, support regulations and whatnot?
Yeah, it's not all that, right? So Sam Altman also said that the models aren't the moat, right? For Anthropic, for OpenAI, for himself, right? The real moat that Sam Altman is looking at right now is memory. So it wants to know everything about you, about your company, right? So that's the real moat around it. Yeah, but they're really not going to encroach on like hyper verticalized solutions. It's not really in their business, right? So, but these horizontal applications like memory, models, like horizontal models, those are going to be most encroached upon by these large players.
Yeah, definitely the vertical, super specialized vertical modes are extremely important. So, I mean, as I was saying, anything of value that others cannot mimic, fast enough. So, like you can solve some specific problems, particularly the consumer applications, quite a number of those will be encroached. Business applications, horizontal ones also ultimately will be encroached, but there are vertical solutions. Let me see if I can give you an example that you can understand in an easy way. So when your company is doing a contract with another company, they may have a 10-year relationship or 12-year relationship. And it goes through 17, 20, 30, 50 changes, that is amendments. One of the things that our customers are struggling is, how do I get the real in effect master contract? Very difficult problem because there's a legal specific. So that is not a problem that, for example, OpenAI wants to solve. That is not a problem that Google wants to solve. So those are the kind of modes that you need to look into, that we are looking into, and how do we differentiate and create a value that no one else can mimic. So it's a very difficult problem. Sometimes you can have up to 50, 70, 100 amendments over 10 years, and it can get very complex with the financial terms and the rebates and all kinds of crazy stuff.
Yeah, I tend to agree with both what Hemant and Mohak said. I think the trick here is how you're hyper verticalized, right? Deep into some segment of healthcare, deep into some segment of contracts that you are doing. And I think those are the value propositions which are, it takes a lot of time, a lot of years, build that subject matter expertise, even know what to do. I think that's where the value would be coming.
For us, everybody is focusing on the code generation problem. But that consumes only 30% of developers' time, right? So the other 70% is left for people like us to solve. So we are intentionally not going after the code generation problem. So let all the big players fight it out. We want to focus on solving the 70% problem. And our goal is to help you get your prototypes, which is these days pretty easy to get to. Ship your prototype into production, right? So if we can solve that problem and be part of your journey, then I think we'll achieve something.
For cloud idea for us, I think the question was, where do we have the expertise? And we wanted to kind of go further down the stack. So we operated infrastructure layer, so sort of a pretty agnostic to what application is running. And we decided to kind of play in that area because there are far fewer companies, only the big hyperscalers and EBS or CoreWeave and whatnot, right? So we create a niche around that.
Thank you
big
so
hand.
much for being here.
So let's get a clap for everyone here. Thank you.
Thank you for coming.
And last thing I want to add, I brought some swag from my company. There's some really cute stuffed animals in the back. They're Ollie the Explorer. If you don't take them back with you, I have to fly on the plane with them again. So please grab them, bring them home to kids, dogs, whatever you got.
Let's take a picture of us together.
Yeah.
Yep. Here, we're downstairs.